Fixerbot says.
Welcome. Stream starts in 5 minutes.
Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
T minus 4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning, hacking, exploring, there's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, all knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow. Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know
Stream
what
about
I
to
mean.
start.
Got
1 minute
high
left.
expectations, gonna teach you something new. Learning, hacking, exploring, there's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, all knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
welcome in. So my kid just said this food was not okay to test. It's spaghetti and meatballs, so I'll have to go and get him something else. But it tasted at least everything, which is nice. Yeah, so I was just fixing stuff, of course, right? Yeah. Let's continue with this. I'll just start this. My kid got here, so I'll just sync these. So because it started copying, but I was copying from one place to another, you know, and the other I clicked. I had marked a directory with so much more data than would fit on the tiny hard drive, like 3 times more data. So I'll have to do something else. So I will continue with the backup thing. You know, the reason I didn't stream yesterday was one of my hard drives, I don't know which one, inside the computer was like more like like I said on Discord there, and then it suddenly goes and then it just repeats. So I was like, better take a backup, right? But actually didn't finish that yesterday, but it kind of went quiet after a bit, so I'll still continue the backup, but I think we can do the normal stream today. So and also I'm going training today, so I will stop before 17 today, so it will be a shorter stream. But we still have our VM running here and everything, so since Friday. So we were doing something. What were we doing? Right. So now I have to like remember things here. Yeah, right. So this is actually a TryHackMe room, but we're using it to explore other things too, or rather learn all the tools, you know. So we've been using R2 and GDB to look at what it looks like when it's running, to step through things, to look at the memory, and I'm not comfy yet to look at the memory really, because it's different. We need to make more and better notes and really check it out. And I haven't really like looked at any YouTube videos or anything. So what happened there? So opening it on top of everything. Anyway, let's just start by checking through what we did here. And this is the number 3 one, yeah, right, overflow 3 here. In this example, we're supposed to, this was just a random test. Right, I was just testing to see if these characters, if this really worked here, right? If that really works, that was the test. And it was echoing our input there, so it worked. And then I know this one has a buffer of 140 characters, so this is not enough, you know, to fill it up. So we added 140 instead, and we got segmentation fault. So that's nice, I guess. But I don't want to like just test my way to the solution. And this is I guess this will be the 4th day or something we look at this. Right. So here we put the actual the actual code we're supposed to put in there later, just to test how it's echoing it back. And there we have the bin sh in. Yeah, Friday, we looked at this in different ways. Do I have any notes on this? Or did we just put it in the brain? There's a reason I didn't close it all down. So, here are some of the GTB things we've learned, and about R2, the notes here too. And if we want arguments, we can start it with it or that. And there's all the things here. PDF to disassemble a function. And to do that here, I don't have that in the notes yet, so we'll have to add it, because I think I did here a bit later in this screen here. But we did look at this one. We'll probably get there, because I think there was before this, but maybe it wasn't. So why a million LSLAs? Oh, I was nano in test. Well, and I was changing the length. 30 characters. And testing stuff here. Yeah, this is to test it, right? I was putting it into hex editor. I just made a file with the right length and then I changed it all. And we had to do that without being connected. I might have done it in a different tab, but we don't have anything else open now. So it's only this one left. Yeah, put it in there. So we might have lost that output that we had. Or I might have already put it in the notes, which is like, I don't think so. We might have put it in these notes, of course. So 3 days ago. Here it is, right? Yeah, here it is. Nice. So this might not be the best place to put it, but it's from this. This is the shell code to open a basic shell that it gives us in this TryHackMe buffer overflow 3. Or rather, it's called buffer overflows room. And we put it into R2, did AAA and PDF, and then we got this. Though we can't run it, because it's not a full program, it's just the code, you know, just these 30 bytes. So, we can still look at it, and we also asked ChatGPT to do the same. Or rather, I just sent it this, and it automatically did this. Though it didn't really understand the shifting here. Which is apparently to get rid of this 11 that is it's not a part of it. It's just an extra X11 here that we don't need. Yeah. And this just shifts it like I was going to cover it with my hand. That doesn't work, right? So it shifts it to this side, so it disappears, and then shifts it back. But I'm thinking, will it not just fill up with zeros then? What will end up there? Whatever it is that is shifted back in, you know? Why not just put it there from the start? It seems like a useless thing to do. Anyway, then it's pushed onto the stack. And yeah. RSP X are zeroing this. Right, we're setting up the arguments. Yeah, and this will push, of course, then the address to the string, right? Which is, since it's here, 1 8 16 yeah, so that's how we found out what it actually does. So yeah, this is a syscall then. Exec something it's called, right? So it executes this. So we're just setting up the arguments and calling a function that executes it, which is, well, a shell. So we're supposed to put this in there. So instead of just, oh, let's put it in there, we don't know what it is, but it will probably work. We checked out what it does, right? So let's see what we have here. Oh gosh, we can delete me mistyping it, it's just confusing. So, no registers. Start. Missing debug info, so we cannot run it. Oh my. What is it we're starting, really? I'll have to look at the start. It's a buffer overflow. So the first one is info functions. So here's the main and the copy arg functions. Yeah, so it's this code. Let's actually put an info here. The shell code disassembled. There, yeah, I'm thinking a lot of S's here, right? No, I'm just this. Okay, so first one is just one. It's not this. Then and this is opening the program. The C program with GDB. And after each GDB here we can put some space so it's easy to read. Then we quit it here. And then we did the same, like we just got some basic information. We actually got like the yeah, we didn't get all the things I wanted. When we started, we got then we get info from registers. I would like to see like the stack, right? So let's scroll back up. That's like what we need to do next. And we played around with this for a long time, so it wasn't just this. This is just what I put in the notes. We might add something from the right side or from the right screen too. Yeah, so my kid's food is. So he did taste it. He's taking a bite of the fries and everything. Yeah, so I'm kind of thinking I'll finish this. It's kind of. I think he just tasted a few things. I'll give him some spaghetti meets us instead, that he is every day. But he wants to try new things, and that's great. So let's see, let's do like 15 more minutes and then I'll go get new food for him. Because he just ate before that too. Pancakes. So this time we started it with D, R2D for debugging it. And we did IA, which is like all information or something. I don't remember it. It's in the help here. So it's not all of it here, because it's like infinite, the amount of things you can list, all the commands. It's massive. What was it? IA. Yeah, it says show all info, imports, export sections. So this is the command here. So like basic information about the file first. It's a 64-bit file. Well, little endian. All 64. It's for Linux. Doesn't say much more, does it? Just repeating the same thing a few times. Then we have imports. It's using puts and struct copy. And we were playing around with trying to use printf and stuff in from assembler too. A lot of time spent on that, and I failed, I think. Just messing with getting assembler from Ghidra and trying to make it back into a file without getting any information except from the help. So I should have probably like Googled more or something. It's a fun thing to just experiment. I'm sorry if it's boring to watch. It's fun. Then we have the main. Copy art is here too. The function. We have start and all the other things. And then symbols. We also have main, right? Here. I'm not sure what p-add and v-add are. Maybe we should check that. They seem to be mostly the same, right? But not always. It seems like this would be an interesting thing to know. So then we did AFL. Let's check back. AFL. AFL list functions. So this is kind of harder to remember, right, than GDB. Those commands are more like words. And here it's supposed to know this, and it's supposed to be very quick, I guess. So as long as we don't need to know all of the things. Also, it's hard to kind of search for functionality when if you have to list all of the possibility, you know, here's AA, we need to get more help on this, AC, all of the ones with question marks. You do have to do AR question mark and get a new list. Like here with AF question mark. This is what we got for AF question mark. And then there's the AFT question mark and AFN question mark, AFC question mark. So we can get even more lists with stuff. So it's like infinite commands. I guess not infinite, but I wouldn't have guessed if from reading this one. Let's see here, print current block with format and length. I wouldn't have guessed that this is where we found the PDF, which were disassemble function, right? It's not like you can guess it logically that it will be under there. I don't remember how I found that one actually. I did Google and use ChatGPT a bit. But I didn't Google for, like, we had the help up, but I didn't read it. Maybe I should read the full help of these commands, you know, or tools. So I'm reading this, but I'm also like, I'm repeating it in my brain as it's not enough only for that. And then these, because the colors, I've screenshotted them. So this is the disassembled main, and this is the copy arg. So for since this is an exported, like well, it's the main, but if we did it in assembler, I think we have to type it, right? So all of the things I'm learning is like hopping into one thing. That's nice, but it also, I don't have all the things in my notes yet. Anyway, so we went through these, of course, too, and checked, but we didn't print any like memory here or anything. Oh, AFL, we can get the address here too, but we didn't need it, we can use @. And here is a way to just get the main one. Yes, we can use grep in here, which is nice to have a reminder here. We can do such things. Yeah. So also when we looked at it in Ghidra, I was, you know, it's so huge. This executable, I don't know how big it is, but I'm sure it's kind of huge. Let's look at the listing up the top. Did we have a listing? Okay, no listing. So we didn't have over here. So let's add stuff actually, because we need that. Of course we need that. So hop up. Here. Yeah, why not, you know? Have the base info of the machine here first. And here we can see that buffer overflow is 8264, so it's 8K big. It's not like 50 bytes, you know, or something. It's kind of funny how the executables are so huge. So let's just put it here too. Oh, we can like delete a bit here. This is not interesting. I was deleting. So we have started it several times. So here we have the listing. This is really what's interesting, but also to remember that this is the box, how it looks. So we have these 4 directories, and here we have the secret file that we can only read when we've gotten a shell as this one, that is just UV bitset. So we need to use this one to get that. I'm not sure if I'll continue with this really today, but I want to like get all the notes in here, and then we'll see what we'll do today. I'm kind of thinking that I do need to study a bit, like watching people's videos and like generally getting more information that's not really I don't watch videos on stream, you know, it feels bad. I started watching Al Hasred's video Buffer Overflow, seems great too. Though I haven't really learned anything yet, but I'm not at the end of it yet. And everything is great repetition, and he's a great teacher. So let's see how it was time. Yeah, I'll actually, since I thought of it again, I'll get this down and get my kids some other food. Right. Let's put that food thingy on. Sorry to have to do it at once on stream. Laban, ska jag hämta spaghetti då? Laban, ska jag ge dig spaghetti? Hämta spaghetti. Okej. Ja. Om du vill. Ja. Då ska jag lägga på de här köttbullarna där. Ja, men det här är den köttbullarna vi har. Okej.
VR Mechatronics says, "Hey, I bought some fries." Joker Sec says, "Hey VR Mechatronics. Hello Flixit."
Hi guys! Welcome in. How are you? First time chat. You were sick. Welcome. Welcome. Yeah, so the microwave will beep in 2 minutes, so I can still continue checking the notes, right?
Can you brief me about what you are doing?
Yeah, so this is like started from a TryHackMe room. The first one was actually buffer overflow prep, which was like for OSCP, but it requires pre-knowledge that I didn't have. So I went to the TryHackMe room buffer overflows. So this is the box that we've been using. But I've been using it also to learn some tools. So we have looked at R2 here and at GDB. And we've also looked at... we also open stuff with Ghidra.
Is that a challenge?
Things. It's a learning room, I think. We can open it. So let's see, is it here maybe? Yeah. So this is it, the room. So it's really not telling us exactly what to do. So first it talks about a lot of your theory stuff, but it was like, it's basic stuff, and then it's overriding a variable. And this is like very easy, it's just to make more than 13 characters and you're overriding it. Though it doesn't noticeable until you write like 15 characters, because, well, we changed the exe actually to have one here and here, so we can see it at least, well, already at 14 characters, you know. Since the string is null terminated, it will be overridden with 0. So... and then it was like, oh my god, what happened? Because this one, we had to get the function address. And I was like, I have no clue how to do this. So that's when I started digging into the... actually, it mentions R2 at the start, I think, here, right? But it's not like it's telling you how to do it. So it took me some time to find how to find that, the address for the function. And then I was like, why does it work always? It's always the same address. Even if I restart the box, if I run several of them, it's always the same address. So the same thing always works. So I was like, why? I still don't have an answer, except that it's, you know, it's not set up securely, of course, you know. And then, yeah, this is the one, the pointer to, this is the one with the pointer. So we're supposed to overwrite the pointer to the function here to run. So by default it's pointed to the normal, and then we pointed it to these instead, to test. So then you have to learn some things to be able to do that. And the hint was like totally useless. Check the memory address of the function, and what you need to know, of course, is to know how to do that, because that is obvious. So it's not really teaching it, and that's too bad, really, because it would be nice to have it taught. The actual theory that you would need to learn. It's not. It's just telling us at the very top there, R2, right? So this kind of thing always makes me want to make a better room. So I'm just going to get my kids food. Microwave's beeping downstairs. I guess I'll put this one on, and I'll probably forget to remove it.
Haha. Translated from Tagalog. Sure?
there. I'm actually going to quickly check my phone for as I'm going to drive to the train.
Colin
later.
Swa says hello.
Hello, welcome in. So right, let's remove the sign there. So I'll just quickly check my GPS here, see when I need to drive. I should pop up automatically, I think. It's too long until it's time to go. I'll just click and see. Okay, so it takes about 25 minutes to drive now, but I want to leave later. I want to be there at 17:45. So I need to leave 17:21. So exact. Okay. There's a bit to walk from the parking too, and so. So let's see. Yeah, right. So this is the room we're currently looking at, but we've been using it then to learn other things too. And I could have just guessed, how long it needs to be, since it gives us this. But I don't want to guess. I want to logically calculate and have a well, at least a good guess. And I realized I still don't know if there's a way to just give us the contents of the stack. And since this is on a box, it's not like we can use any graphical tools or anything. We're SSHing. So these are the ones we have. But it gives us this. A suggestion to use Python to send it with whatever length there. And NOPs first. I guess we could just do a long thing, a long thing, and we could just get this, but I want to learn as much as I can from it. So let's Google now. I'm going to duplicate this tab because I don't want it to hop away somewhere else here. And let's Google here for let's do R2 stack. I want print the stack contents. Is there such a command? So yeah, print stack. How to get a nice stack view. So after entering a visual panel mode, this is a view from Immunity Debugger. Can I get a similar in? Okay, so they still visual panel mode. Hey, this is great. I'm happy if I get this. So no one ever says the command, right? Here you can see what they're looking at before underneath. Nice to have the clear terminal here, right? So we can see they're looking at sheets. For example, there in the Google. Oh, that's nice. Funny. I don't like the clear one though. It kind of not pretty on stream, right? Or ever. Hi, Panda.
Panda Tongue says,
Win
Oh,
Roth.
that's a giant
Translated
emote.
from Slovenian.
Thanks. Cool. That's a cool new feature actually from Twitch. To have the possibility to make you giant emotes. Yeah, it's a bit terrifying. As a tiny emote is cute, but now you can see that the eyes and everything.
It's terrifying.
Yeah. You have several ways to print a stack. The specific way that you're searching for is called stack telescoping. And you can print it like this. PXR at ESP. So let's try this. But first, let's continue looking at the old things and make sure we have everything in the notes, before we start new things. So, oh my. Open a new tab in the wrong place. Why did it open that tab? So it opened Google for the place I'm going training. So I'm hopping back here to the page we were at so we can see it. And I'm popping up the notes again, so we have that. And then let's look at this. So we have the code in the notes. This would just test. This is to see if the Python commands work with these special characters here and stuff like that. And then I just listed it again, right? Because I made an actual the shellcode they give us. I put it in here. And we did that on my machine, so it's not here. But I found it in the notes, and I'm repeating now because I know there are new people, so that's why. So this is what the room gives us, and with R2 we could make it disassemble it for us. So it simply runs x86 sets up the arguments to run a syscall to execute binsh. That's what it does. And since this, apparently this will also bring along the CUID that is set on this one. As you can see here, the S over here. Right, you can't see that very big, right? It's kind of tiny. Can I increase it a tiny bit? Whatever. So I think I shrunk it all down to have it half size before. We can just, oh my. Whatever. I guess that's okay. So that's why we had that there. I can reconnect it. By the way, let me just start it. So the box is started, because that will take some time. Not a long time, but still. So the notes are up again. So AAA, and then we have the listing of disassembling the main function, and that's copied to the note, so we have that. GSDC, right? So to go back to commands here. Right, wrong one. We had at first we had in the notes we have GDB, then we have R2. So DS and DC. DS is one step, execute one step, and DC is continue execution. So we stop stepping through it and just run the rest. So that's what we did here. DS, DC. to test stuff, and OOD to run it with an argument. So I just gave it an argument to test that, and it worked, meaning this opened, and then we did what? Alright, we looked at symbols again, we looked at right, so I added to my notes while we were doing it here. So list register contents is dr, and then we listed the main again, and then I started trying with px here too. Address example using, okay, yeah, so px is list memory contents, and I edited my notes by mistake there, so it said AA after. So yeah, dsdr px rsp, and I totally forgot we did this. But when I tried a lot, let's see. So what happened there? Right, we're in GDB. So I was like, what happened to the colors? So we're trying GDB to do the same thing there. Right, so we're GDB now. So R2 has the nice colors, not GDB. Was there anything here that I want to add? I had PX already. It's already in the notes. We'll have to use them better. So now we're going back to GDB. I'm hopping to those notes. And let's see. Disassemble main. I don't have this in my notes yet. So this was new. So we'll have to add it. Well, let's put it here. So well, kinda no comment needed, right? Disassemble function. Right, we could also do function name. So we don't get the pretty colors.
Your airplane is loud.
Yeah, it is. So Stockholm is there, Arlanda is there, so, and that's a bus. Sorry. I can put like filters on, but then I sound funny, you know, so I think since they're not always there.
I thought it was over my office, it's so loud, ha ha ha.
Yeah, sorry. Okay, so IR is in GDB to check the registers. And I'm kind of assuming info registers, right? Because it's usually both words and not, right? Did I have the help here for it? We do. And here we actually have a long list of things. I would like to get this from R2 So info registers, info R, and apparently IR, right? So info functions. Maybe disassemble should be after this, right? after getting the names of the functions. So I've double spaced get register info. Oh my god, I can't spell. Or type rather. So R, starting program, R for run. Right, so the question is, should we do anything like having IR here? Run or R, quit or Q. We can do like or IR. Apparently it works because that's what we have here. R, starting program. Here's a program that echoes out because we have no input here, so it just echoes nothing. And then I guess it's finished running. And then we're listing some oh, so complicated. I don't know why they do x/, because you can set it, has nothing to do with hex, because you can set it in different formats, right? I think so. I think we did. So x / 200. I wish I remember more about this. I should have made notes at once. So I'm just copying my command here. And then we got information. And then we kind of like, I had to stop for some reason, right? So I was just checking how much time we have. We have 2 hours. So it's already been almost an hour. That's crazy. Crazy. Time just flies. And so far I haven't done much. I'm thinking I'm going to clear this out because it kind of gets messy after a while, right? So let's SSH again and let's check what the IP of the new one is. So we have now 70.83. So playing around with this makes you more comfortable. See how many times we connected. Why does it list it all? I don't know. It's not pretty. So am I typing on the right machine? We'll know. It's user1 password. Why couldn't they have done password? It's not much difference. So checking here again, and we're going to go to the 3.1, and in here we have these 3 files here. So sorry, switch screens too, right? So this is what I meant with it's not pretty with all the... What? It's still here! Who told me to use Control L? It just jumped down. It's still here. I wanted to clear the buffer. Okay, so we're aborting this. We didn't have to do that though. So SSH. So clear is definitely better. That's what I wanted to do. So whoever gave me Control L and said I should use that instead, that was not correct. Then I can continue using clear with a clear conscience. So user1 password. Alright, yeah, so now we're spamming YouTube chat. Oh, Message redirected. I've never seen that in YouTube.
Nur Islam says hi.
Hi. Welcome in. Welcome in. So, let's see. So I'm typing in the right screen here. So we're playing with this file, and right now I want to test the command in GDB. So we're doing GDB buffer overflow, and I'm going to try and remember how it works. And I have my notes for help.
Nur Islam says, heart.
John
Heart.
Rosemary says, hello.
Hi, hi. How are you? How are you, everybody? So, for me, it's like, I'm like, how was your weekend? Because I didn't stream yesterday. That's very odd. So, what's my hard drive problem? So whoever is in the Discord will get notifications when I don't stream. Or at least I will send messages. I'm not like spamming people with them. I hope. So, GDB notes, GDB. So we run it with run. And we can append an input. So if we do like this, we should get a feedback here. Here's the program that echo your input and that. So now it's like finished again. We can do quit to quit, which we don't want to do now. We can do break in a function name to add a breakpoint. We can do next to step a line, next I to step exactly one instruction. Continue to continue normal execution, jump to an address to jump there. Okay. And we can do info. I have things I don't know here now. So let's try IF. Will that be the same as info frame? Yes, it works the same, right? So if we so my brain tells me start is the command I'm looking for. So if we run start, we debug it with stop at the beginning of the main procedure. And why didn't I have this in my notes? I don't know. So let's add it. Didn't I add this? It's so strange. I talked about it like at least twice. So runs the program, but stops. Yeah, start is a good one. Starts a program but stops. At the start of main. Right? So it doesn't just run it, it's just starting it. It's not doing more. So if we do start now, now we should be able to next and also check the stack there and stuff. So if we do IF now, then we have something here. But I want like a full list of things, right? So we can also do info. I'm curious now. IF, will those give us info functions? Let's do the full. You know, it might be several things start with F. Apparently it was, or in this case, right? Oh gosh. When it pauses, I'm like... It used to be useful when we didn't have a buffer. So we have copy arg and main over here. Those are our functions. So this is interesting. It's a kind of long list. So how come we get so much more when we do this with GDB than with R2? Maybe we should open one tab with GDB and one with R2 and just compare the command output we get. So I'm thinking it's time to queue that, right? And to scroll up into this is kind of a long list. That's a long list. So now we know why we can quit the printing the list. Oh right, IF was the frame. So now I know it. So I'm curious how you would make a short form of info functions. So let's also do info registers. So here we can see stuff. And some of them are in this information too. So here is RIP. And it also says saved RIP because this is the current frame then. So this is where we'll hop back then. Org list at local saved at, and this is the same. Previous frame SP is. So this is. So it's like checking more back too. Okay. Save registers. Oh my. It's interesting that we can do this. So now if we do hop to my Googling here. PXR. No, this was. I'm thinking this is wrong. This is. We have to Google again. So let's duplicate this and Google for like almost the same. Or whatever. But now we want GDB, right? So how to look at the stack with GDB. Oh, so such a nice article. I like the look of this. This looks nice. I was chatting with someone yesterday and mentioned they don't really understand exactly how the stack works and how to look at it. So here's a quick walkthrough of how you can use GDB to look at the stack of a C program. I think this would be similar for a Rust program. I'm going to use C because find it a little simpler, and for a toy example, also you can do terrible things in C more easily. So our test program, here's a simple C program. Sure, stack string 10, stack int x equals 10, char pointer to heap string malloc 50, print, enter a string for the stack, get stack string. This is a nice example. Maybe we should just do this and compile it. And this is why I'm saying we're like basic on the TryHackMe, you know. This is where we're getting the thing to research, but we're doing it just checking different things, right? So right now I'm actually going to open a new tab here. And leave the poor box logged in there. And let's and let's nano stack heap.c because it's showing both, right? So let's paste it all here. And alright, I did the funny stuff, trying to whatever. So stack heap c stack heap. And we're getting a warning because gets is not secure, which is nice. But it will still have compiled it. So we have stack heap here. So we can use GDB on it. And now she will tell us how to look at it, right? So let's see. Did she have something special when she compiled it to G? Flag compiles the program without debugging symbol, which is going to make it a lot easier. Alright, so we'll recompile. Let's recompile it with G. And O0 tells GCC to turn off optimization, which I did just to make sure our variable didn't get optimized out. Oh, right, we want it to be the format it was. I think this is what it says. It's kind of hard, so let's actually copy this and let's paste it here. It's a capital O and the 0, right? So we're still getting the warning, of course. And then we do GDB. There, start it. Because she says so. So, well, let's follow along with this thing. It wouldn't hurt to learn more stuff, right? This is also nice. We're compiling test programs. We can use G. With the bug symbols. To make it easier. Tell CG, CC, turn off the optimizations, not to get stuff optimized way or changed. We want to see when we test stuff. We want to see, so that's nice. So it prints some stuff about I like this stuff. This is no one like trying to use too fancy words then they're not comfy with or whatever, you know. It prints some stuff about GPL and then it gives a prompt. Let's create a breakpoint in the main function. This is what I've learned. We don't need to, right? Because using start instead of run, it will automatically do it. So I'm hopping this. And they're running it. So we'll just type start instead because it does the same thing. There, it just makes automatically a breakpoint here in main. So we don't need to. Two, look at our variables addresses. Let's start out by learning about our variables. Each of them has an address in memory, which we can print out like this. Oh, nice. Nice, look. P and variable name. Yeah, and here he ordered the heap string before the stack string for some reason. We're going to do this, of course, but I'm thinking notes. We can't miss making notes. That's like the most important thing, or we will just not remember everything, right? So if we don't make notes, we will forget. So GDP P and variable name. Now we only have the short version, right? So P here's the help all. So let's go to P. MNOP. Yes? Ska jag komma gubben? Okay. Right, so it's not sorted on letters. Jag kommer snart. Eller jag kan komma nu då. So, tell me. Wait a minute. Det är nog för att det är gängor som blir en skruv. Ja. Va? Ingenting. Och nu är det ju dag, inte kväll. Det var därför jag sov igår istället för att gå till jobbet. Jag inte kunde sova för att jag fick hjälp med. Jag vaknade när jag hade bara sovit några timmar. Så kunde jag inte somna på jättebra. Vill du något särskilt? Ska jag sitta och jobba? Jag tycker att du ska vänta lite ungefär. Sorry. So my kid just wanted to tell me some stuff. Right. So let's continue down. I'm going up and down, right? So what if I search down from here? Then it tops back. So what is P? I'm curious. I need to know. So P. Oh. So what we get, we will know soon. So let's P. Oh gosh, I'm typing there. Have to click the new screen too. So P and X. And then we do P and let's actually just do PX. Thought so. P and now I found it. Heap string. And stack string. So this is kinda, you know, just random data, right? So nothing has happened yet. So instead of following her thing, yeah, let's do that. But I want to step through and see how these change now. But let's continue with her guide here. So if we look at this, let's see. Each of them has an address in memory, which we can print out like this. So I'm thinking P is just print, right? So yeah, I do want examples here. I don't have any examples yet, and this is definitely help. So, and then we have examples. We don't have any examples yet, which is like, why? I should have like example output for all the commands. So we can actually put the so so this will be more fun later, right? Oh, right. I'll just do this. Yeah, that will fit. I'm just running Total Commander in the background. Bit of backup. So, if the hard drive is too noisy, you'll have to tell me. I have it right by the mic here. Oh, it's warm and nice. Kinda liked the warmth from it now. So... Tell me if it's too noisy, we can pause it. Maybe it's actually too noisy. It'll go forever, so I'll just pause it. So if we look at the stack and those addresses, we should be able to see all of these variables. Concept, the stack pointer. We're going to need to use a stack pointer, so I'll try to explain it really quickly. So the hard drive did not go quiet, as you might hear. Now maybe. There's an x86 register called ESP, called a stack pointer. Basically, it's the address at the start of stack for the current function. In GDB, you can access it with SP. Okay. That's a noteworthy thing. So, print address of variable. And then we kind of show that P printed the variable, right? Let's do and SP. I'm thinking like, should I type shortcut for? Let's do stack pointer. Well, it's not always ESP, but there. Basically, so there's also a start of a stack. Okay, I'll read it again. There's an x86 register called ESP, called a stack pointer. Basically, it's the address of the start of the stack for the current function. In GDB, you can access it with $SP. When you call a new function or return from a function, the value of the stack pointer changes. Step 3. Look at our variable on the stack at the beginning of main. First, let's look at the stack at the start of the main function. Here's the value of our stack pointer right now, so let's do it. So this is why I didn't start stepping into it, because I saw this. So, and SP. No symbol SP in current context. Oh, I did and. Sorry. Of course, there's no variable called SP. So let's actually copy this too and put it in the example section of the notes. here. There. 1, 2, 3, 4, 5, 6, 7. So why does it number it like that? Right? Why? Well, it doesn't make it easier to read, it makes it harder to read. Almost. Do one we already have done, just to see what it looks like. So the stack where our current function starts at. Cool. Actually, we can make this bigger. So why should you have tiny text when you don't have to? I have to scroll down a bit to where we were. Here, SP. Now let's use GDP to print out the first 40 words. 160 bytes of memory after the start of the current function stack. It's possible that some of this memory isn't part of the stack because I'm not totally sure how big the stack is here, but at least the beginning of this part of the stack. I've bolded approximately where stack string, heap string, and X variables are and color coded them. X is red. Let's do it ourselves. So this is what the number after the X's is words. Thank you, world, that I finally know this. So I should have read something before this, I know, but you know, when you can just test stuff and stuff happens, that's fun too, right? So X40 SP. So we have a different format. Yeah, I missed the X. So the X is nice to see it in hex. This is prettier. So this is why. This is what we wanted. This is why we were starting to do this, you know? So we're not going to stop read here. We'll of course read the whole thing. But this is very important to bring to the notes. Oh. So printing 40 words in hex format, starting at ESP position, right? We could just do SP. I'm trying to be like obvious, right? So printing variable addresses, well, and in Swedish we only have one D. Addresses and some contents before varying it. My god. So I should practice typing, right? And I don't really type in any planned way. I did for a bit try to learn the real way there, but I was like, I don't have time for this. It's quicker just to do it from what I'm used to, you know. You have to relearn. So I'm typing quicker than I can, apparently. So starting Starting program. Using start, which sets an automatic breakpoint at the start of main. There, so that's where we are now in the program. And that's where I want to continue from, right? So some examples. We don't need to do this with everything. Just a few things that feels good to know, to have. So now we're using this on our machine. We didn't do it on the actual one. So let's transfer the knowledge here. So I do not remember what the variables were here. So I do have the code very easily accessible. So let's just look. This even was up when I missed it. So we have buffer. We have string, but when we start here, we don't have any. Except for R. Yeah, I guess we can do RC and RV, right? To have something to test with. So if we P, of course I printed in the middle of printf. I typed characters. So P and buffer is not here anymore. It's not existing yet. It's the wrong function. RC PRC. So did I start it? Yeah, I did. So P. Okay. Let's restart it, and I'm not remembering how to do that, or if I can even. We have to start it again with start, I guess. I'm sure it has its run, then we can give it an argument, right? And let's give it 2. Well, it doesn't take 2 arguments. Let's give it 1 argument. Yes, we want to start from the beginning. And now, still nothing. Use a file command. So maybe because these are specials.
Madam Fabulous says,
Hi.
GM.
Good morning. Yeah.
More boff?
Yeah, I'm actually reading an article with they have a nice example code, some nice example code with 1 string variable on the heap and 1 on the stack, and commands to look at the stack and stuff here. So let's continue with it here. So it's just this simple program with 3 variables, and here's the heaps malloc and stuff. So we did compile this program, and we did, yeah.
Cool.
Here we can do $SP. We're learning more GDB here. So $SP is the stack pointer. We don't need to like mess about to find it or something. So we just did this. So I'm sorry for more buffer overflow stuff. But I need to learn the details to really, know it all. I want to know it all. I want all the knowledge. I bullet approximately where the stack string, let's see, we read this. So X is read and starts at. So these are the addresses that we got before when we did P and X, P and heap string, P and stack string. So that's why we know where they are.
Nothing to be sorry about. Learning along with you. Ty.
Okay, great. Yeah. You're welcome. You're welcome. Thank you. I bolded approximately where stack string. Right. So X is at 27C. Right. C, D, E, F. Right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 8, 9, 10. Oh, I said 10. 9, A, B, C, D. I must have messed up. Did I start with 1? Yeah, then it's fixed. I should start with 0. Then it's okay. Yeah. Don't count too many times. Heap string is blue and starts at 80. Stack string is purple and started to 8E. Right. So that's a funny place. So it's this. I have to do it again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So it starts here, really. They did it a bit wrong, I think. So it doesn't matter. So this is at the start of the main function, so they're not really even, these lines has not even happened yet, right? Or they may. I guess it's the first actual instruction, that's where it pauses. I think I might have bolded the location of some of those variables a bit wrong here, but that's approximately where they are. Yeah. So it was a bit wrong. One weird thing, you might note that there is an X, there is number 5555, but we set it to 10. That's because X doesn't actually get set until after our main function starts, and we're at the beginning of main. Yeah. So they're not initialized yet. Look at the stack again on line 10. Let's skip a few lines and wait for our variables to actually get set to the values we initialize them to. By the time we get to line 10, X should be set to 10. Right, so B test C10. First, we need to set another breakpoint. Oh, that's how they hop there, because I was thinking we'll do next a few times, and how do we know exactly at what line we are, you know? Test.c10. So we can actually set a breakpoint in our C code. So this is a copy to the notes for sure. So we have break here, function name, but now we have a new one to add. That is, oh gosh. So I'm just pasting with the shift control and we don't only get the text. So this is example of setting break point on C files. Line number. I'm like amazed that this works. That's why there are exclamation marks. I'm like impressed. I'm impressed here. So it's not like the 10th instruction or something, it's the 10th line. I guess that's how it works when it does it like in an editor. What do I want to hop to really? I'm thinking I really want to hop to the code, and it's here, so I didn't put it in any notes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the empty line after malloc. So all variables should be set at this point. So since we're having the same, we have the same code here. We can do B, but our one is called stack. What did I call it? So stack heap.c. Stack heap.c. Colon 10. Very nice, logical. Breakpoint 2 at file stack heap C. Line 11. There says that too. It says line 11. And continue the program. Continue here. I think I have this in my notes already. Continue RC to continue normal execution. So let's do C and use what we have learned. Continuing, breakpoint 2 main at stack heap.c 11. So it stops before line 11 when we set the breakpoint to 10. That could be like interesting. So I'm thinking of eating something. I shouldn't probably. I don't know. So I should be healthy. I should like lose some weight even. But I've been sick too, right? Just a bit, just a cold. I was losing my voice during streams last week, right? So yesterday I went back in with my kid, and I was like, every up, I was like, it wasn't back to normal. So I didn't bike to work today, actually. I didn't, because I'm going training later. So, alright, we have 1 hour left. Then I have to go, like, I have to be with my kids a bit before I leave. And I'm leaving at 17:21, it says. I have my GPS up there with a traffic check. Oh, look. It just like goes down when I'm supposed to leave. That's kind of nice. So, a lot of traffic until then. Or rather, I'll probably get into a lot of traffic. Everybody driving from work, right? I'm supposed to be there 18. So, continue, we did this. Okay, let's look at the same things again. GDP is formatting the bytes in a slightly different way here, and I don't actually know why. Here's a reminder of where to find our variables on the stack. Also, they're colored and nice here, right? So let's see if it does it differently for us too. So the other one was X40SP, and now she's doing X80X SP. Why? Let's actually do X40 and 80 and see, because the difference shouldn't really be there, right? So this should give us the same, well, kind of same as her, because yeah, and now she's fixed the alignment that was bad before. So we can see that the values have changed a bit. So she has different memory addresses. So here we have our 10, A with a 10, and then we have, it should be like the full next line here. Should be, yeah. Well, hers is totally different, which is not strange, but why do we have so many zeros? Let's actually look at where the position is for ours. So we have DD40 and DD36. DD40 and DD36. So DD40 and so which one did I actually read? X, DD4C. So now I'm confused here. What did I do? I didn't scroll far enough. The values were odd there. Yeah, for C. So C. This is C. Yeah, 8, 9, A, B, C, D, E, F. So this is C for C. And then we have 4, 0 and 3, 6. And they were swapped from when they were in the C code. This one is actually first. So I don't know why it was asked that way. What did I do? Or were they this order? I don't think so. I have to look. Let's look. Yeah, X is actually in the middle. Right? Or rather, yeah, it's in the middle. Because these are like... But I guess this will still... I've never thought of it, you know, more than this is just saying where to store. And this is that. That's what we're getting now. Where to store it. Well, this is also getting where to store it. But I guess it's storing it there too. So, I know that I'm slow. I'm like getting a bit stressed, and that's make me slower. I shouldn't try to stress. There's no reason to. But DD36 and DD40 doesn't at all match with hers. So 3, 6, 0, 1, 2, 3, 4, 5, 6. and how much. Because she had a full line. That's what she had. And that's not impossible, but what is this in between here? So I'm like, this value, what is that really? Let's go back to the text and check. So I like this one. First of all, let's see if there's an RSS and stuff. I've never really looked at this before. It's a blog. Oh well, can look later. So her heap string, and I still want to hop to the top again here. So heap string is the last one. So sorry for the cars. So we have hours before her. So before digging too deep in how these were like, let's read what he says. There are a couple of interesting things to discuss here before we go further in the program. How stack string is represented in memory. Right now on line 10, stack string is set to stack. Let's take a look at how that's represented in memory. We can print out the bytes in the string like this. Alright, so there's no reason for me to try and realize where they are, right? Because we can just print them. So let's do x 10, or I guess it's not 10 but 10 hex stack string. Right, and she's getting an odd format now, but we're not. We're getting the same. Hers just changed. Well, and of course we have to do heap string. And we have to do x. Oh, is it like this? Yeah, I thought so. I think it's wrong. I think we have to do the ands. So I like this article a lot, but we also have to be like not just blindly listen here. So for x, of course it's not 10, right? It's more like 4, I guess. No, it's not 4 either, because this is
Dev Sutar says Sui55 I'm back. Smiley face. Good afternoon.
Hi.
Romantic cat face.
Good afternoon. Welcome back. You're so welcome. So I'm trying to. So this should have been 1 because I was counting bytes and it's not that it's there. So x is just 1. X is just 1. And we get the right one with adding the and character t. So she missed that in the article. And here we have the contents of. I don't know how long this one is and why she did 10 to not get so much, but it's not like all of this is let's see what she says. Right now on line 10, stack string is set to stack. Let's look how that's represented in memory. We can print out the bytes in a string like this. The string stack is 5 characters, which correspond to 5 ASCII bytes, 73, 74, 61. Oh, so it actually says stack. I had no idea. We can also get GDB to show us. Cool. Yeah, we can do S. Let's do it, of course. Hop to the stack string one and do, instead of X for hex, we do S. Was it S? Yeah. Yeah, and I had 10 and she had 1. That's why we got lots of other stuff. So interesting. Lots of learning here. So let's continue. How heap string and stack string are different. You'll notice that stack string and heap string are represented in very different ways on the stack. Stack string has the contents of the string stack. Heap string is a pointer to an address somewhere else in memory. Yeah, but does it actually say stack? Here are the bytes on the stack. I'll have to look at the code again. So, yeah, it says stack. That's why. I was like, why on earth? But it actually says stack there. Did you see? So the string is there. It doesn't say stack. That would have been so crazy, you know, when it's... yeah. I was... What? But the variables contents is stack, that's why. So I didn't read that they set to anything. Heap string is pointed to an address somewhere else in memory. Here are the bytes on the stack for the heap variable. So these bytes actually get read backwards because it's x86 little endian. So the memory address of heap string is 5555555. So now we have that is 1, 2, 3, 4, 5, 6, 7, 8. So then we know that we should have had 2, right? And hers, this is what confused me, you know. Here we have like this amount, and then she get a different format, and I was like, what? But it's not a full line of mine. For mine it's just 2. It's just that hers is, and also this one is from here then. So, and wherever it ends, if it ends here, right. Yeah, her selection here is also more. So how long is it really, and how can we know that? The memory address should like be long, right? Or rather, it should be shouldn't it be like 64-bit, right? That's like the thing. Heap string is a pointer to an address somewhere else in memory, and this is their example. And of course, it's little endian reversed. Another way to see the address of heap string in GDB is just to print it out with P. Yeah, this is what we did first at the very start, because I saw the and here, and I removed it. So, but we haven't done that since we started, so let's just px, should be 10, and then we p stack string. I'm like, what was the name of the variable? Stack. And p heap string. And I remember that this is set up to get a buffer overflow, right? So we're copying this 10 one, and that's why it's 10 maybe. Enter a string for the stack, enter a string for the heap. Stack string is, heap string is. So we're not doing anything together with them. X is. Okay, so we're not setting X. Okie dokie. I should have read that more carefully from the start, I know. How stack string is represented in memory. Stack. This, here's where we were at. Now the byte would represent the integer x. X is a 30-bit integer, and the bytes represent it are. We need to read these bytes again. The same reason we read the... Alright, yeah, we did that already. Okay, we initialize the variables. Now let's see how the stack changes when this part of the C program runs. Okay, so first let's hop to to hours and actually look at our... So I'm thinking the address on the stack. I would like to see this. What is the actual address? So it's from here. I'm just thinking, is it usually this kind of number? So if we do and this again, we get this. And then the other thing is the value of it, of course, what's on those addresses. And then we have the heap one. And DT40, and that's what we printed somewhere here. So however far it goes, if it's this, if it's this. So the only sad thing with this one is that she's not certain, right? You say I probably did something wrong here because she's not certain how long they are, so you should just select some that she thinks is about the right place. That's what it says in the text. So I would have liked to know exactly, right? But since it's 64-bit, I'm assuming 64-bit addresses, right? If there's not like some extra data there to tell what kind of... That's what I thought that they meant here with a stack. But it would have been too uncomputery to put the text stack there on ASCII. That's like crazy, right? So we're about to read
Opinion
into it
says,
here now.
Afternoon, fix it.
Good afternoon. Good afternoon. So we're playing around with GDB and learning how to find things there. And the person who wrote this article isn't sure how long the address is, but I'm thinking since it's 64-bit, it should be 64-bit addresses, but I'm not sure. Is there some other data? When there's a heap memory allocation address as a pointer? Let's just hop up to the C code, you can see quickly here. So, so this shouldn't this be 64-bit?
What's this binary exploitation?
Yeah, so we're doing buffer overflow. So I need to learn more to do buffer overflow in a perfectly controlled and perfectly understood way here. I want to know all the things, you know. So where are we? So we've done this, and I'm just checking time. Yeah, we have lots of time left. I think might be able to finish this one. Like the article, that is. How heap string and stack string are different. Yeah, so we read that. And that. And that. Here it is. So that's why I held the mouse in when I dragged up, because then I can just go away, you know, to hop back. And by mistake I right clicked, so it lost it. We need to set another breakpoint, so let's do that, right? So do we remember how to make a breakpoint now? So B, and this is awesome that we can set a C line breakpoint in this. Wonderful. And that's, I'm assuming, why we included debug information when we compiled it, right? Otherwise we couldn't have done this. I'm assuming.
Okay, so you'll probably be typing at Ome point D. Have you seen Al-Hazred's introductions into buffer overflow?
Yeah, I haven't seen all of it, but I was watching it at work before. So while I was doing other stuff, so I'll have to focus too on it, 100%. But it seems great. Very, very nice. He's a great teacher. I think it was called stack heap, see? Colon, what line? 16. So, make breakpoint pending on future shared library load. Oh, that's a new one. So, I might have misspelled it.
It's really good.
C.
I actually used that FTP program back in the day, so I was probably PWD without knowing lol.
Oh, cool. Yes, I remember War FTP, the name, but I don't think I ever used it. Yeah, a lot of people probably had that problem.
Yeah, it was really popular.
Yeah. So I listened to how far? I don't know how. I started at home to watch it, and then I started from the start again, because I was still not like... I was doing other stuff both times. I should have focused only on it, but I haven't had time yet. So, I will do that too. Yeah, so if you have any other great tips, because that one I knew about, but it's a great tip. So for everybody else, let's actually... Is this it? Yeah. Here you can see how far I was. Bad characters. So I think actually I saw a bit more too. But when I wasn't
Honestly,
like,
after watching
I wasn't
that, I
looking.
concluded it's probably the best explanation and demonstration I have seen on buffer overflow in 30 years.
Yeah. So great one. Let's actually click the share link here. So for chat, it's easy to Google, but here it is. This is a great video we're talking about. It's so great, and it says he's just been streaming for a few weeks or something, so it's just starting. Yeah, definitely.
Al is up there with the best in the world, in my opinion.
He can really explain things too. I mean, it's a lot of people know a lot of things, but not a lot of people can explain it so everybody understands, right? That's a great skill. So, let's see. Yeah, and make it easy for everybody. Let's hop back to this one, because this is great too. And even if it's not perfect, you know, I had to add characters because they were like saying print the address of the things here. No, where was it? I don't remember. Anyway, it was also the wrong place. It's great anyway. So let's go back now. I scrolled so too far away again. There's another article. Interesting.
So breaking this process down into
Yeah.
phases, where are you at right now?
So right now I'm just trying to find, I was looking really for how to be able to see the stack with R2 and GDB. That's where I am. I need to see the stack so I can see what's there. I know that Al, he uses Windows, right? And we're SSHing to this box, so we don't have any graphical things at all either. So it's R2 is mentioned at the very top of this room, but it's not like we're given any instructions on how to use it or anything. So I'm Googling and testing a bit slowly and learning these things so that I can use them, and making notes, of course. So I've done this several days.
Okay, the only thing that will be different is the tools.
Yeah. So it's learning the tools that's the thing, you know. I understand it. I understood it before I started with this, but I still need to have the tools to be able to find the data and know how to, you know, change it and things, you know. That's the thing. The tools. You need to learn the tools. That's a tricky
The
bit.
theory is still the same, I think.
Yeah. The question is if memory changes, addresses and stuff, and, you know, he was using a Windows XP, I think, because it's not as safe as today's. If we would just install a Windows machine and try and find stuff, it would be much harder, right? And try overwriting the stack, and there would be like safety things hopping up saying, oh, you can't do this, right? He mentioned so anyway, like traps in the stack, if they're overwritten, it checks, you know. That's kind of how I understood it. It's where I didn't say anything about it more. You know what I mean, probably, right? So Windows is safer.
This is why I'm starting from scratch on HTB Academy. Most of what I'm being taught I know I'll read, but the tools and methods have vastly improved, and learning them will make the more advanced stuff much easier.
Yeah. So learning the tools, that's the thing. I mean, we could like... now this room isn't teaching it, and that's a bit sad, you know, because if it had been teaching it on TryHackMe, I wouldn't have had to Google and find for example, Letterhead's video and other things. But it's not teaching it. It might be saying like this buffer overflow prep room. That's Saberi's room, by the way. He says like, you need this pre-knowledge, and here's an article where he's written stuff, but it's just, you do this in the tool, do this in the tool, do this in the tool. It doesn't say, this is why we do this is what happens, this is what's happening in the background, do. You know, you have to have all the pieces, and just getting to know, search for this in the tool, find this line, that doesn't help, you know. You need to know all the basics first. So that's why I hopped back to this one, and even further then to learning the tools themselves. So we just added some stuff here, like these ones, for example, and I think we added this assemble too today. So this is great stuff. And this R2 tool, first, if you do question mark, I just tested H in here, it didn't work, help didn't work, but question mark just randomly, and I got this, and then I was like, yeah, it said here at the start, append question mark to any chart to get detailed help. So I did a question mark, and then you get these, and a lot of them has question marks. So this is just one letter. There's a whole alphabet here, you know. So a few other letters and combinations I've done, but there's no way to like search. I want something for stack. I want to see stack information. Then you have to Google. There's no good help in R2. There's a manual, I guess, but I mean, I would love to be able to search in the tools these.
Great to see you again, Fixit LFG.
Great to see you too. Yeah, so let's continue. I know I have a limited time today here. I have like 30 minutes more, and then I'm going to go training. That's why. So I have a limit. I have to be able to get there. I have to talk to my kids a bit first. Make sure they don't need any more food or anything, which they will definitely want.
I've seen smaller encyclopedia collections. Then that help menu.
Yeah. So this is just crazy, the R2 question marks there. The number of commands here, it's not like logical. Sorry for that. So we printed the PDF here, command was print current block with format and length, and the PDF that we found from somewhere else was disassemble function. It's not like a logical jump from P to this, so I wouldn't have guessed that I should list P, right? That's how I do disassemble something. I guess it's printing something. Let's continue, see if I get a bit more in this. Yeah, we're going to step a bit more, right? First, let's make sure, because we're about to lose this, right? So we're probably not going to continue it though, but we just started it and then we hopped to this article. And the commands that worked on this executable did not work here, and I'm assuming this is not compiled with debug information, right? So it doesn't work. So that's nice to know that if we have a random one, these commands won't work anyway, right? If we have a random executable we want to check out. But it can help us to get an overview how stuff works. Right, I should add that to the notes. GDB might require compilation with debug info, and where's the other one? This one, of course, with C. I'm assuming this requires this one. Let's do probably instead. Probably requires compilation with debug info. I'm kind of sure, but I'm not sure. Didn't read it anywhere. It's just assumption that we don't get information about test C generally, right? When we compile stuff. Hopping to the article again, and let's actually hop to the next step. So we created a breakpoint, so the next thing is just to continue C. And the article says continue, and we will learn that C is the same as continue, so enter a string for the stack. So very nice string, right? Enter a string for the heap. There you can see my keyboard. X is 10.
Fix it. Thank you for pretending that I understand what you are working on.
Okay. So, we were prompted for 2 strings. Let's look at stack string first. Yeah, so it's finished running. Can we still see the variables? Right? So let's look at stack string. Yeah, I was kind of thinking this. There need to be another breakpoint. So our breakpoint failed. To set the breakpoint failed. So we need to restart the whole thing. So I'm just... Right. We started with start. They started it with D. So it's time to go to the notes and see how do we restart this. I'm thinking I remember, but I think I remembered what it was here. Right? OD. And here we need to do start or run with input.
Pop ret something.
So I'm restarting it so it's fresh, and I'm going to start by adding a breakpoint at let's just do main, right? And then we add a breakpoint at stack heap dot c colon 10. This is great repetition to learn. And then we add a breakpoint at 16, right? So now we have all the breakpoints that we need. And this time we didn't get an error when we added the number 16 one. Now we can run it with R. And we will hop to the first breakpoint. So let's see. What do we want to do here? We might want to check the values, but we already have done this. So let's just continue. It's the last step. That is the actual one that we wanted. So now we're here at the print.
Main.
Yeah. Yeah, so now we should have all the variables should be set in everything.
Then you
but
should
the
be able to
last
see
one
what's
is
in the stack.
16. Yeah. I'm thinking we should continue one more time and add the values, and then we will be able to see it. That's right. So let's do the same one again. There. And now we should break. We got a segmentation fault. So this means I didn't remember 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I can just add 9, you know, when it's 10. So that was my bad. But we got a buffer overflow, which is I mean, it wasn't bad, right? We have the breakpoints. We don't need to restart it again. We just do R again. And we just say that we want to start from the start, and we do C 2 times. We could have just done the 16 one, right? So now we enter 9
I think what
characters.
you do is you mark where the address is by throwing that a thing to fill the buffer and find the overflow.
Yeah, exactly. But this is just to look at the stack, at the contents of a stack. That's why I'm doing this. So I'm not trying to make a buffer overflow. I got one by mistake. That's the problem. So the other one is malloc 50. So here we can type more if we want to. So for now, I want to look at the
Translated
stack.
from Tagalog.
So I broke my test by typing too much. Now I couldn't check the variables, right? I couldn't look at the stack anymore. It crashed. So now we can look at the stack, and let's type from memory. So x / 100 and space and $SP. And I forgot the X. There's supposed to be an X here to see it in hex. So here we have our 10. I remember that one was at 3, 4. Let's actually cheat by scrolling to the place where the string is actually in hex. Here, 73, 74. This is their. Oh, that's the base string, right? I have to do what I entered. Okay, I'm cheating. I'm cheating. So let's see here. 2 hex.
What was it saying about the heap string?
Just a sec here. I was just
This is how
here.
the memory is laid out, right?
This is how the memory is laid out. So if you can find 31, 32, 33 here. Here. 31, 32, 33, 34, 35, 36, 37, 38, 39. So here we can see that this actually takes more space here. And there's... yeah. That's 4 of these. But this is a funny order, right? So they're all backwards. I hate Little Endian. I must say I hate it. It's all backwards. This is good to know. It's not just... the string is also backwards. It's not just memory addresses that are backwards. All the darn thing is backwards. So let's just look at the others. One. Let's put a few 20s there. And let's do this one. Which was my other string here. So 61, 73 is the other string, which is not here, right? This should be the memory for this. So why am I even looking? So we're looking now for the memory of, let's see, what's the memory of it? I can just look again. So trying from memory to P, and
I was going to A, it's little Endian, yes lol.
yeah. So yeah. A string. It's string. So this is the address that it is at. The address. So 40 DD 40. So address to the actual memory should be here. So what if we try, oh gosh, that's annoying. Let's keep that selected. I can type anyway. P
So what is at that address? The start of stack allocation?
The string. Our string that we entered. That is 60, 61, 73, 64, 67. I should have done like A, right? That's easier to find than actual text, test text. So 0x, my god, I don't know where it starts. So, assuming it is formatted in the same way here, that it starts going back here and then it goes back on the next one. So that's would be A0 first, right? No, but it's odd. Yeah, but it must be. Yeah. Because I was thinking all of it was like backwards. Is all of it backwards? This confuses me. 33, 34, 35,
yeah, I think
36,
it comes out to something easy to find.
38, 39. Yeah, but we couldn't have seen this then. You hadn't seen this if it all had been just the same, you know? So this is good that I did the 1, 2, 3, 4, 5. It's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, null. That's what I wrote, you know. This is the variable contents. It's a string, our string. It started at, that's why I thought it was odd first, because these are not DD34 is where it starts, and this is like, so 34 is there, 35 is there, 36, 37, 38, 39, A, B, C, D. No, that's wrong. What did I say? Yeah, 4. Again. 4. Was it 3, 4? 1, 2, 3, 4. It's odd. It's odd, like in not even. It's split up. I have to check. 3, 6. It's 3, 6. Then it's okay. Because 3, 6, I remember wrong. Because it didn't work. That was one too much. So 3, 6, 3, 7, 3, 8, 3, 9, A, B, C, D, E, F. Then it works. So, right. So if this works the same, this should be the first, second, third, fourth, fifth, sixth, seventh, eighth bit of the address. Let's just, oh my god, I don't have to click. So 1611.
This is above my pay grade lol.
Okay, A09255555 55550000. This is a very odd address. That's a number. I want to format this as a string. I don't want an OX. I just want this. How did I do it? No, the address needs to be hex. I don't want the output to be. Oh, didn't they do something for that? So
Back to the manual again.
yeah, right. So we printed strings. We printed the string even. The string stack here. So we can't use it with, we have to use the X one, right? So if I click, now I have to click here. So let's do X10 instead, and S for string. Oh, let's see. And let's do, instead of the address, I was curious to try though. So it cannot access memory there, but the P command worked.
No memory address.
Yeah, I thought this is an odd number. That's kind of like the reason I wanted to try this. So what if we I know how to get it. We use the P, but we do what's the variable name? Heap string. No, but I got it here, right? But now we're going to do this just without the and then we get the actual contents of it. There. And here we can see all those 5s. We were not very odd off, but we were backwards. I'm backwards. So I shouldn't have turned it around. That's what I shouldn't have done. See? So I turned it backwards. Yeah, I turned it backwards. Now we're going to do this again. But we're going to change it. So it's backwards. So A 0 9 2 5 5 5 5 5 5 5 5. And the zeros are the same. 1 2 3 4 1 2 3 4. So now it's exactly reversed, and we get this, which I'm assuming.
Endian messing with our minds again.
Yeah, so I turned it manually when it shouldn't be because it was already turned. So maybe this is the reason why we have little endian. Because then we could just read it, right? Yeah. So what I was going to do now was, I'm not sure if I can change the output format of that, but we can change this to hex, right? And then we can change the hex. Let's open a new one. Let's do it here.
It's an easy mistake to make, like being left or right-handed. It's difficult to work one way or the other.
Yeah. So now we want to change this to hex first. And then we want to change this to characters. ASCII. I know there's something, it's just annoying to find. What's this? Right, encode text, decode text. What do we want to encode or decode, right? It's messy, but it's supposed to be ASCII in here, right?
Fix it. Can I make a request for a future stream?
Yeah, sure, go for it. Can't I type here? ASCII. So I think that we were wrong with decode. Let's try encode. And let's do US ASCII. It's called US ASCII. And
would you do like a walkthrough of Cyberchef and how to use it and when, etc.?
Yeah, but then I would have to learn it better first. You see how I'm struggling here. But sure, we can play around with that on stream. You see, I'm failing. I've done this before. I just don't remember how I did it. So this doesn't work. But maybe we can just ask it to generally... Or I can just generally compare this to the other one I had.
Ha ha ha.
Translated from Tagalog.
So, this is not the same, right? It's not the same. 61, 73, 64, 66. It's not the same as this. So we can't get it out in the correct format, but we can see the addresses here. So this is what was the contents of there. And alright, look.
I don't mind.
No, it's mixed.
I know people really rate it, but I've never
order.
really found anyone explain how to get the most out of it as a tool.
Yeah. That would be nice. We'll have to learn it together and then make a stream on it then. So, look, I changed it. And did we get the same response? Not really, but similar. So I'm just pasting this instead here. So we're still getting garbage. And this might not have to be that, you know, it's just... so this is what I typed, I'm kind of sure. Oh no, I didn't. I did this line. This is what I typed, right? So, but it's still
the ASCII
not
type
the right
correct?
thing. I don't know. There's no other ASCII, and there should be like 2 ASCII. Wait, there's 2 hex. How often do we convert to ASCII? You know, if you just reload the page here, so start as it is. When you start it, you have 2 base 64 from base 64, 2 hex from hex. Why not put 2 ASCII from ASCII? Right? It's basic stuff. So if I search for ASCII here, there's no ASCII.
It said US ASCII.
Yeah, it said US ASCII. And you're right. My special characters didn't exist, but the other ones would have been there, right? So my special characters would have... They're not 7-bit, they're 8-bit ASCII. And this was 7-bit ASCII, so... You're right. It might have just thrown it all off.
That's what I was thinking with your funny alphabet in IKEA land lol, D.
IKEA alphabet. So, we should have a special IKEA alphabet one here, then. Anyway, I could get back to this one, it's kinda nice. So I was just curious if this... We got a number, you know. We got a number here. And this is not said that it is hex, so I'm assuming it's decimal. Yeah, this is interesting. I love this stuff. Someone else might be, oh my god, so much boring things. I'm like, oh my god, this is fun. Yeah, so that's, it didn't say OX. So let's look up for now how we can format P. So GDB, P, format, and not printf format, output format, and this is GNU. Yeah, but can P do this?
How much time do we have left? Fix it.
I saw it. I saw the answer. It's very simple. We have like 7 minutes. So I saw the answer. It is just this. And we get it in hex.
Oh no.
Right, so it just returned the same value back to us. That's useless. Alright, I think I understand the P now. I think I understand the P. But it's also very odd that we would get this. Or did I break it with a PX? Let's see. I just saw it here. PXPC.
What does the P do?
That's what we don't know exactly. What is really P? GDB P, because I couldn't find anything. There's a lot of P. Here, print variable maybe. Print counter. Yeah, let's do print, because that's what I kind of ended up thinking, that it's just print, right? So if I do print 1 2 3, it will say 1 2 3. If I do print x 1 2 3, it will do it into hex. And if I print a heap string as hex, and if I print heap string as hex, and if I print heap string as s, we get this. So now we can do p/s too. So that's what I tried to do with Cyberchef. Now it's solved. We can use all the formatting.
Prints the mem address, right?
Yeah,
Nice.
yeah, with the and. That's a normal way to do it. It's like C-ish, this, you know. So we're actually using kind of like printf with the s and everything. It's that kind of thing we're doing. Here. So I snagged the word printf somewhere out of this too, I think.
Write IT down in your notes. Sorry to shout.
Yeah. Right, this is what you're supposed to write into the notes, definitely. And also this, we can take the link. This is nice, the format list. So let's put it here. So P. Let's actually do print airline, because it seems to be the same. Print. And or P. So, and then we have P/x print in hex format. S for string, There. And we have the link. So. Nice. And just, these are kind of normal, right? D for decimal. Unsigned decimal. Octal. Why we would want that? Maybe sometimes. The only odd thing is T for binary. T stands for 2. Alright. So base 2. Base D. Deca or whatever it is. X for hex. T for base 2. Okay, maybe I can remember that. A for address. C. Yeah, so I tried C. Character constant. I think C is what she ended up having by mistake. And F is floating point number. So it's the normal like C stuff. The star one is easy to find. So if we go back and we do this as, I have to click before I can arrow up. If we do this as C, we will get them separated and we won't get the text, I think. No, we didn't even get that. But I got that when I was printing memory. So if we go to, gosh, here. So this, if we do here C, then we get this very odd format. It's not very useful, right? Well, also the window is too tiny because of this font size. Ah. So hex is much
Judd
nicer.
got back from ads.
Okay. Yeah, I've just been continuing to test stuff. Yeah, so since I need to leave in less than an hour, I think I will spend some time with my kids, get something to eat before I leave. I'm going to go train some Bujinkan. It's fine. And I haven't been doing it for 2 years. So I was thinking I have to get in better shape. Just have to get a little less on the tummy. And I'm going to continue biking to work.
A break will help.
A break. Yeah. It's a tough thing to... it's not like I'm mega fat, but I should definitely... clothes are suddenly tight, It's not... They shrunk. I don't know what happened,
This is hard to learn.
No! Do you think so? It's more like we have to dig a bit for the information. I think that's just fun.
It's the reason high-level languages exist.
Yeah. Yeah, but my first programming teacher, when I was in 7th grade, he taught all, binary maths and everything. So I think I have a lot of stuff it's like native language stuff. It's not like I know binary or anything, That's not how my brain works. But it's not strange with having the different bases. We did maths with octal stuff and hex, of course, and binary, and we made assembler programs and machine code. But mostly we did basic. First we did Pascal, then we did basic. Yeah, I think. So, and my 16-year-old is currently doing Scratch, a lot of Scratch. So he's finally he's done so many things with Redstone in Minecraft. He programs these command blocks in Minecraft. I said, you already know programming, but it's still been a tough step to take anyway. So we tried to make Java mods, but he was like, this is too complicated. So now a few years later, he's getting started again. Yeah, so let's see who we can find to raid. We need to raid someone. Oh right, it's working again. And there's actually someone on the list except for me. That's nice.
Madam Fabulous says,
Lisp/Scheme was my first language.
Ooh. Ooh.
Specialist at Northern
really
Virginia
used
Community
that,
College.
actually. So, oh, it's the job hunting dude again. I think he's going for an hour, so we can rate him.
Woopinion says,
Have a wonderful rest of day. Fix it. See you again soon.
You too, and I'm sure I will, because I, as I said, it's been 2 years since I trained this. You know, I like martial arts. It's nice. So I'm going to do raid, and then have not the full thing here with HTTPS and everything there. So have a great day, everybody. Thank you for being here. Even though most people might think this is like, oh gosh, that's boring, that's too, you're slow, it's slow level, whatever, you know. But thank you for being here. And see you tomorrow.
It was cool.
Yeah.
Madam Fabulous says,
Victory hand.
Thanks for keeping me company. See you tomorrow. Bye.
Woopinion says,
Don't worry, lol.